So first of all is the general overview of our project, which is a IoT parking monitor with surveillance. It's a security system of a car parking in the landed houses. The main objective for the system is to secure the car that parked on the parking at the house. The system that includes with 3 types of sensors, which is infrared sensor, ultrasonic sensor, and microphone sensor. So the objective of the system is to monitor the car with a camera and data provided that goes in and out the parking through the smartphone application. Next is to the parking the car safely without hit the barrier in front of the parking. And lastly is to notify the car's owner when their car starts or the sounds around their car through smartphone. Next is the justification of IoT integration. IoT safety parking monitoring with surveillance need to be integrated with IoT to ensure the car that has been parked will safely be parked within users are allowed to be monitor their car just by using smartphone through the application provided. The first is input. The components involved for the input of the system is an ultrasonic sensor, infrared sensor, and lastly a microphone sensor. Next category is output. The output of the system is a camera, an LED, and a buzzer. And for the input and output, we use Wi-Fi module and also Arduino Uno board. And lastly, software used is Proteus, Arduino IDE, and also Blink. Next is the block diagram. Arduino Uno in the middle with the 3 sensors, which is ultrasonic sensor, microphone sensor, and infrared sensor giving input into the Arduino Uno. Next is we have 2 relays, which is the output from Arduino Uno, which will turn on the LED and the buzzer, and also the buzzer. Next is we have a camera as an output from the Arduino Uno. Lastly, we have the Wi-Fi module, which goes through and forth with the Arduino Uno and the IoT application and also the cloud.
So we move to the flowchart process. So first start, and then when the system is started, there are 3 sensors, right? So from the left side, the ultrasonic sensor. So first, the ultrasonic sensor will detect a car presence in 400 meter range. So if there is no car presence in 400 meter range, it's going to back to ultrasonic sensor again. If it's a yes, the data will go to Arduino processing the input. So then the Arduino will give a data to a relay, and relay going to magnetize. So there's going to be a 2 output, which is LED and buzzer, and it's going to end. So we see at the middle one, the microphone sensor. So if a microphone sensor detects a 45 dB to 100 dB sound, and if it is yes, Arduino processing the input. So they're going to be a 2-way. First is going to relay magnetize and buzzer will trigger. And the second one, as you can see from the Arduino processing the input, is going to go to the receive the data using Wi-Fi module. So there's going to be an IoT application and move the data from Arduino, from the microphone sensor, to save the data to the cloud, and it's going to be end. So we see the right side infrared sensor. So if it is a detect car presence in 150 meter, so it's going to process the input and send it to the Wi-Fi module, and Wi-Fi module will receive the data using Wi-Fi module, and it's going to go to IoT application and save the data to the cloud, and all the process is going to end up with the end. So next, the view of user interface. So the user interface can monitor the parking with the camera. User available to check the data when the car goes in and out. User will notify when there's a sound on the parking. Next, as we can see here, this is a system designed based on Proteus. So we have a 3 sensors above there, and every output, buzzer, LED, buzzer, and LED will connect with the relay first. And as you can see there, there's a virtual terminal where the virtual terminal is like our application there, when you can see the data on there. So here, when the ultrasonic sensor get the value, the LED and buzzer will be triggered, as well as when the infrared sensor get the value where the car goes in, the virtual terminal, which is our application, is going to will save the data where the car is parked into the garage.
Advantage of the system: user can monitor the date and time car get parked and out. User can monitor and watch the parking with the app. User can easily park and did not hit the car bumper into the wall. Business opportunity to market the system. Due to the car theft case increase, this system will help reduce the possibility for the car get thief. This system also can be marketed to the owner of landed house. If they're not in the house, they still can monitor their car that parked on the house by just using the app. The car owner as well will get the notification on the phone when there is car in and out from the parking scene. It have a data login. Target user and customer. The owner of the landed house, customer that have more than 1 car on the house, customer that always not around the house.